Use Herons' formula to find the area of triangle HK and P. Herons' formula is useful to find the area of a triangle when you have all three sides. Notice that for this triangle we don't have the height, so we can't use the famous formula 1/2 times the base times the height, because again we don't know what the height is. However, we do have all three sides, and to apply Herons' formula, we're first going to calculate this term S. And S is calculated by adding all three lengths, A, B, and C, and then dividing by 2. After we calculate this quantity S, we're going to use it to find the area by applying this formula. So let's begin by labeling all of my sides. I'm going to make 10A, I'm going to make 12.2B, and I'm going to make 12Z. You can label the sides however you want. This is just the order that I chose. So I'm going to begin by calculating the quantity S by adding all three sides, which is 10 plus 12.2 plus 12, and then after I add them up, I'm going to divide by 2. Now 10 plus 12.2 plus 12, that's going to give me a total of 34.2. And when I divide by 2, I'm going to get a total of 17.1. So S is equal to 17.1. Now that I have the value of S, I can calculate the area by using this formula. So I'm going to get the square root of 17.1. And then I'm going to multiply that with the quantity of S subtracted with A. Here that's going to be 10. So I'm going to get 17.1, subtract 10, multiply it with the quantity 17.1. This time I'm going to subtract B. B is 12.2. And then I'm going to multiply with the quantity 17.1. And we're going to subtract it with my final side, which is C. And in this case, that's just 12. And all of this is going to get affected by the square root. So I'm going to begin by simplifying these quantities here. So now I'm going to get 17.1 multiplied with 7.1, since 17.1 minus 10, that's going to give me a 7.1. So 17.1 minus 10, that's going to give me 7.1. 17.1 minus 12.2, that's going to give me 4.9. And finally, 17.1 minus 12, that's going to give me 5.1. Next, I am going to multiply these four quantities together, and I'm going to get about an approximation of about the square root of 3034.4.04, and I'm going to approximate again by taking the square root. So once I take the square root of 3034.04, I'm going to get an approximation of about 55.08, and that would approximately be the area of triangle HK and P.